Good afternoon. I'm Michaela Hutchinson, a PM on the Visual Studio for Mac and Xamarin teams. And today I'm going to be telling you about all of the things that Visual Studio for Mac can do beyond mobile. Mobile is the thing that we have mostly talked about up to this point using Xamarin. There was a great session this morning with James Montemagno that I'd recommend checking out if you want to hear more about that. But today I'm going to be focusing on games, cloud, IoT, all the other things. And I will be also telling you a few tips and tricks. Okay. So Visual Studio for Mac is a modern multi-platform .NET IDE. It allows you to target all of the different .NET platforms from one place on the Mac. It's a native Mac experience. It's for developers who enjoy working on a Mac, who want all of their apps on a Mac to feel native. Native experience is something we feel very strongly about, but we also try our best to make it feel like a Visual Studio experience as well. It supports mobile development via Xamarin, web and server development via .NET Core and ASP.NET Core, game development with support for writing code for Unity projects, also serverless with Azure Functions, and preview IoT support. So I'm going to be telling you a little bit about all of these things. First and foremost, it is a .NET IDE. It is not just for developing with .NET, it's also built on .NET. It uses the Roslyn compiler platform, NuGet, MS-Build, the same templating experience used by the .NET command line tool, Visual Studio Test. All of these great open source components are at its foundation. And these are the same things that you use with the command line tooling, with Visual Studio Code, and Visual Studio on Windows. It also has full support for the .NET standard. This gives you access to a huge ecosystem of libraries via NuGet, and it's also a fantastic way for sharing code between the different platforms that you're targeting. You can share code between your Xamarin apps, your .NET Core apps, your ASP.NET Core, and at some point in the near future, also Unity. ASP.NET Core is a great way to write modern web apps. It is fast, it's open source, it supports all of the modern development paradigms. It's great for ASP.NET websites and cloud backends for your mobile apps too. So I am going to show you a quick demo of this. My demos will be a little brief because I have a lot of different things to get through. There was also another great session on ASP.NET Core I'd recommend checking out. So this here is the Visual Studio for Mac main window. I'm using the preview version because I want to show some preview functions such as functions and IoT. So from here, I'm going to do File, New Project. And here you can see all of the different platforms that are supported. You have these great multi-platform app templates here, which create mobile apps for iOS and Android, and also create a .NET Core backend for that. I'm going to start by taking a quick look at that. So we'll be using Xamarin Forms. I'm going to give it a very unoriginal title. And you can see here that I'm targeting both Android and iOS. And I'm going to add an ASP.NET Core Web API mobile backend for it. I have the option here to use Git for version control. There's a lot of Visual Studio for Mac has all of the development features you would expect from a modern IDE, including full integrated Git support. So I'm going to just go ahead and create that too. And when I create this project, it just takes a second. Now it's loading. And here we go. So here you can see an Android app with the structure you expect from that, an iOS app with its info peeler, storyboards, all the iOS things. And these are sharing code via a shared project here, which has the Xamarin Forms code that's shared across the two platforms. I'm not going to go into those now. As I said, I would be focusing on the other things, not so much mobile. But there's plenty of great resources online to find out more about this. So here you can see our app service, which is the back end for this. It has a controller. This is a very simple to-do app. It has a list of items. The app can post items. The server keeps track of them. And as you can see, this is a very straightforward ASP.NET Core app here. We have here our models, the item and item repository. And I'm going to just show one of my favorite features here, which is that you can actually set up your project using run configurations to actually launch both your mobile app and your backend at the same time. So I'm going to go to the solution options here and look at the configurations. Go down to the run configurations here. I'm going to create a new run configuration called app and backend. Create that. And then here in the options for that configuration, I'll set it to launch our iOS app and our backend app. Here I can place a breakpoint in the controller. You have all of the options you would normally expect when debugging. So I'm going to just place a quick breakpoint in the get item. Now I'm going to go ahead and build and run this. So while it's building, you can see here that if you tried out Visual Studio for Mac, this doesn't look quite like you get it out of the box. I've changed the way that the editor looks with a dark theme, because I like that's my personal preference. We have a huge range of themes that you can choose from that you can see here, and there's a sort of live preview. So you can just, like, as you cycle through, you can see all of the different themes. But that one there is my favorite. I've also enabled some additional things like visualization of white space, changed lines, code folding, a few things that are off by default because they complicate the experience a little, but I personally find them very, very useful, and I'd recommend looking around the options and trying a few of them out. And if you have any questions, feel free to send me questions. I'm happy to provide more tips and tricks. So here's a simulator. I click on that. Okay, that does not seem right. Okay, let's try this again. think. That's the problem with having so many demos. It's easy to forget things. I think somewhere in here there might be okay, here we go. So, of course, I have all the code navigation, go to definition and all that, navigate around, find references to this interface. Here's our view model. Aha, it's using the mock data store. But what I actually want it to do is to use the real data store. So if I go over here to the app.xaml, here we go. Run that again, and now it's going to actually use the service. So you can see here we're using dependency injection to register a mock store for local development and a cloud store for cloud development against our app here. Okay, that would help. I also need to set it to actually use that run configuration there. There we go. Now it's going to actually launch the server. Okay. Now why is it not debugging that? Make sure I build it. Okay, looks like the app had trouble connecting to the service there. That was most likely because the service wasn't actually running. It's still building. You can see the build output down here. Okay, this will teach me not to update things right before I do a demo. Should still work though. I think that was just the Android app building. And we are looking at the iOS app. Okay, I am going to move on. But trust me, it does work. This is also the perils of working with preview bits as well. I do strongly encourage you all to try out our previews, but I would also recommend keeping the non-preview bits side by side. As you can see down here, I have two copies of Visual Studio installed. One of them is the stable one, and one of them I renamed to preview and updated to the preview version. So I'm using the preview version right now. Oh. Okay, so moving on to Xamarin Mac. This is our binding to the macOS native UI toolkit, Cocoa. So this enables you to write native Mac desktop apps using C# or F#. It shares a core with Xamarin iOS. It's actually open source, and you can see the URL there if you'd like to check it out. So it's based on a very well-tested, mature technology. And there's also preview support for Xamarin apps. So that will enable you to share code between iOS, Android, and also Mac Desktop and UWP, and support for other desktops is in the works. And this toolkit is actually used by Visual Studio for Mac itself. Various parts of the UI, such as the main toolbar, are written using Xamarin Mac. So I'm going to show you a quick demo of that. Now again, I'm going to do File, New Project. You can see here also, in addition to app, so we have a range of templates for creating Mac apps. You can also create various types of games, sprite kit and scene kit games. But I'm going to go ahead and create a basic Cocoa app. You can see also here there's support for F#. I'm not really an F# user. I hear that it is a wonderful language, but I have not yet had time to get to grips with it. I'm going to call it Hello Mac. See here we have a little preview of how it'll look in the dock. And here is our new Cocoa app. So you can see here it has an app delegate like iOS apps. Very similar concepts here. There's an info plist. Again, the same thing. You can set your app's identity, the name, the bundle identifier that you would need to ship it in the App Store. There's also support for registering your app to handle various kinds of URLs if you need to do that. And if you want to edit the raw plist, you can do that here. So this looks very similar to developing a Mac app in Objective-C or Swift. And here in our view controller, you can see it's inheriting an NSView controller. That's the Cocoa equivalent of a UI view controller. And here we have a storyboard file. So there isn't a drag and drop designer built into Visual Studio for Mac UI, unlike iOS and Android. But if we open that by double clicking, that will go ahead and actually open in Xcode here. So I can go ahead and add a button. To the middle of my view controller here, with a nice big button. And then I need to do this complicated little thing with viewing the related files. So I'm going to go ahead and pick this is how the designers work in Xcode. It's a little unintuitive if you haven't used it before. Here we go. So here's our view controller. There we go. Okay. Not sure why it's not picking up my file, but I can pick it manually. Go ahead over to the view controller here. And then I control drag this button and drop an. Okay. There are occasion. Okay. The integration with Xcode is not the most robust thing in the world, unfortunately. But if I save this and go back to Visual Studio for Mac, you can see here in the designer file it's created an outlet. So I go ahead to my view controller, and in the view did load. I'm going to add a quick event to that. to the activated event. I'm just going to write hello to the console. And I'm going to go ahead and run this. So Xamarin Mac also has bindings to all of the Cocoa widgets, so you can add maps to your apps, browser controls, tree views. You can write document-based apps. It exposes all of the Cocoa APIs. So you can see here our app. When I click on this button, we hit our breakpoint, as you would expect. And you can see here, it looks exactly like a very simple Mac app. So moving on, as I have a few more things to get to. Oh, not sure why this keeps skipping back. So next up is Unity. Actually, before I go into this, I've noticed a question just came in whether Visual Studio for Mac supports F# development. I did mention that very briefly, but I didn't show it because I'm not an F# developer myself, but it has very rich F# support, full IntelliSense, the interactive window, templates for a range of different project types. It's a very pleasant and robust F# experience. So moving on to Unity. If you want to write games, Unity is one of the most popular choices. It is a very easy to use game engine, has a bunch of great features, all of the features you would expect from a game engine, and it runs on almost any platform that you can imagine. It's a great choice for developing for HoloLens or other AR platforms or mixed reality platforms, such as the upcoming mixed reality devices. All around, it's a great choice, even if you don't want to write games, if you just want to write something that has 3D interactive experiences. So I am going to show you quickly how Visual Studio for Mac helps you in Unity development. So here I have a Unity project. This is a very simple project that is included with Unity. When I run it, it just shows off some of their particle effects. So you can click to create explosions, and you can cycle through different kinds of things. So here it's showing fog, steam. You can click to create steam. That one's a little hard to see. Spraying water. So there's a whole bunch of cool particle effects. So I'm going to show how Visual Studio for Mac helps you write the code that powers the gameplay of these kinds of games or apps. So by default, Unity doesn't include doesn't use Visual Studio for Mac as its editor, but if you go into Preferences, then External Tools, you can set it. By default, it uses MonoDevelop. You can see here I've changed it to use Visual Studio for Mac, just like you can do on Windows. So now I've done that. If I double-click on one of these scripts here, such as this particle scene script, it opens a solution up in Visual Studio for Mac that contains all of the code from the Unity project. You can see here a little extension I wrote with some more tips and tricks that you can install from the extension gallery. I'd love to hear if people have ideas for more tips that I could add to that. So once it's loaded, you can see here is that file that we saw in the Unity project. It just navigated straight to that, and I can actually attach this to Unity here. So I click Run. It just attaches straight to Unity. Okay, that is not expected. Nope. That is not good either. Okay, I'm going to briefly switch networks. Looks like one of my apps needs internet access. I have a very cool demo to show in a bit, which is IoT support. And that doesn't work very well when it's connected to Wi-Fi. It works much better when I have it connected to a little hotspot. Okay. Okay, PowerPoint appears to have crashed. Okay, so I'll just open this up again, take a quick look at that. Hopefully it works this time. It looks like there was actually a null reference exception in the scene control file itself. Okay, there we go. Okay, so now it's attached to Unity. When I run this, now when I click Navigate, that activates this next method here. And you can see here we've hit a breakpoint from Unity. And of course you have access to all the locals. You can inspect the various Unity objects, change values, all of the normal things you'd expect to do while debugging. You can step. And it's a pretty great debugging experience. There's also some other really helpful features that help with Unity development. One of the things that's often kind of tricky about Unity development is that you have to know the names of special methods. They don't use virtual methods. The engine checks for methods with particular names. So if you don't know the names for those, it's sometimes difficult to do development. However, Visual Studio for Mac has support for including all of these in IntelliSense, even if they aren't actually virtual methods. So you can see here I can just go ahead and create a method like that. And you can also see the code analysis from Roslyn here in action. You can see here there's the private modifier has been grayed out because it's redundant. So I can just Alt-Enter and remove that redundant modifier. You could also see there are a number of code actions. There are code actions. I could convert it to a static method, for example. Another really useful feature is that it actually restructures the solution tree to look like the files do inside the Unity project. If you look at the solution that Unity generates for Visual Studio for Mac to load, it's actually quite complex. It ends up having 4 different projects, each of which has their own little substructure. But in the display options here, it collapses it into a view that looks exactly like the view you see in Unity itself. Okay, so I'm going to have to get PowerPoint running again. And Azure Functions. So Azure Functions are a great way to write apps that scale up and down very easily. Your app isn't running on a particular individual server. You just have these little self-contained functions that can be triggered by various inputs and can return various outputs. The Azure Function development model is very straightforward. It uses a class library project with attributes applied to the functions. And there is preview support for this in Visual Studio for Mac. The preview support is based on the mono runtime, but we are currently adding support for the new .NET Core 2 based Azure Functions, and we will be switching over to that soon, as that's much more tuned for server environments and so on. So these functions automatically scale up and down across multiple servers, so you don't actually have to care about the details of the servers. Fortunately, I created an Azure Functions example already, because I'm running a little bit behind. So here we have a Functions app. So you can see here that it references a number of libraries on NuGet. The project itself, if you look at the source code of the project, is actually a modern SDK-style project using package references and so on. Just like .NET Core and .NET Standard projects. Okay, so I appear to have opened this in the wrong version of Visual Studio. So this is a very important point here, which is that the function support is currently in preview. So you need to be using a version. You need both to be using the preview version of Visual Studio for Mac, and you also need to install the preview extension, which you can do from the extensions gallery. You can find it just here. Refresh. Here we go. So I had installed this already. Here we go. So I installed that already. So when I open the functions project in this, it actually has the option to run it, which I didn't while I had it open in the stable version. So this is a very straightforward function. It's just a hello world function that takes a name parameter and returns hello name. I've placed a breakpoint here already. It's running, and you can see here in the application output down here, it's started the function running. There's a lot of debug output. So we can see here that the function has been detected from this function name attribute that we applied to the static method. And here is where the function is hosted. So it is on localhost 7071 API hello. I'm gonna and so I just did a quick get of that, and you can see here we've hit the breakpoint, and the name is the parameter that I passed in via a URL query string. And so we're in the breakpoint here. You can inspect the request object and so on. And when I return, you can see that it returned a file. Actually, curl would have been a better option for that, because it downloaded a file. There we go. If I run this again, here we go. So you see the actual string that it returned in the response of that HTTP call. And so this is fully local debugging, but you can upload these to Azure and it'll just scale out. You can have, it can trigger on, for example, event bus messages. It can output objects to blob storage. You can set up these really complex webs of functions that trigger each other and build very complex apps that aren't bound to individual servers. And now we have my most exciting demo, which is IoT. This is another preview feature. It's another feature that you have to install from the extension gallery into the preview version of Visual Studio for Mac. And you can see here I have a little Raspberry Pi with a couple of LEDs and resistors connected up to it. And this is currently actually connected to a Wi-Fi hotspot running on my phone, because that is the most reliable way to connect it. So this adds a new project type to Visual Studio for Mac, and we also have an extension for Visual Studio for Windows as well, which isn't available right now, but that will be available soon. And this allows you to write an app in C# on your Mac and then deploy and run it on a remote Linux device over SSH using the Mono runtime. So it's very simple to get Linux up and running on a Raspberry Pi. You can download images, burn them to SD card, put that in the device and boot it up, and you're ready to go. And then you need to go into the Pi options and enable SSH, which you can actually also do by editing a file on the SD card, so you don't even have to ever connect a monitor to your Raspberry Pi. And then you can deploy to that object, to that device remotely. So I'm going to just go ahead and close out this project and open another project that I created earlier. This is an IoT project. Now, again, I had to install this from extensions, and that added a new template, so I could go here and create an IoT console app. But I've gone ahead and created one that will control the LEDs on this Raspberry Pi here. First of all, I just need to make sure that that I'm connected to the same network as this device. That's always the perils of using SSH. You have to make sure that the devices are both reachable from each other. And now you can see it's connected to this Raspberry Pi device on the local network. It actually automatically detects the devices from the way, because they advertise on ZeroConf. And so you just tap the device and enter your password, and it connects over SSH. But I've connected this already, so I'm going to go ahead and run this. Okay. Maybe it wasn't connected. I'm going to just restart that. Sometimes the connection gets a little flaky and it thinks it's connected while it's not actually still connected. I'm going to just once you've developed your IoT app, you can also use MKBundle. There's built-in support for taking your app and the runtime and all of the assemblies and converting them into a single file where they're all bundled into one executable, which makes it very straightforward to deploy them to devices if you're deploying, say, a whole fleet of IoT devices for measuring the weather or tracking doors or whatever kinds of things you might want to do with IoT. And the IoT projects support .NET Standard 2, of course. You can add NuGets to them and use those to do REST, to connect your IoT devices to the cloud or to Azure IoT Hub, for example. So let's try connecting this again. OK, here we go. So it wasn't connected to the device, and now it's connecting. And it's connected. Good. OK, so now it's deploying. I have a breakpoint here in this little loop, but it should be go ahead and deploying. It's deployed the app over SSH, and it's hit the breakpoint. So we can see here we have these various pins. So it's just there's just a little loop here that is turning the LEDs off off and on one by one. So if I remove the breakpoint and resume it, you can see here that we have this little sequence of LEDs being controlled directly from the pins of this Raspberry Pi by C# code. So this is super cool. There's all sorts of things you can do with this. I like the LEDs example because it's very obvious what it's doing. It's very visceral. You have some LEDs and resistors and stuff, but you can also connect USB devices, cameras, buttons, weather sensors. There are all sorts of devices that have been built for Pis. You can just plug onto the ports and access those from C#. So this isn't specific to Pis. Pretty much any Linux device running SSH will do. The Pi is the most widely available, though, so it's the one that all of our examples use. The IoT runtime doesn't actually contain any device-specific libraries. It's just a BCL, so to access the GPIO ports and so on, you need to use additional libraries or pinvoke into native code. There are some libraries on NuGet that do this. Like, for example, there's this Uno Square Raspberry IO library here. If I just go to definition on one of these things, you can see in the assembly browser that it's quite comprehensive. It has support for the camera, all of the things like I2C if you wanted to connect things like temperature sensors. It's pretty comprehensive, so there's really nothing you can't do. I'm gonna just okay. I have a little bit of time, so I'll show off a few more things. So here we have. You can see here we have Alt-Enter extract method based on Roslyn with previews just like on Windows. You can there's context actions, so I could, for example, convert this while loop to a do while loop. There's literally hundreds and hundreds of these things. You can see in preferences here, in source analysis. This is all of the issues that it can detect and in many cases fix. There's also all of these context actions. Alt-Enter is my favorite keyboard shortcut. it's definitely, if you're going to remember one thing from this talk, I would recommend remembering Alt-Enter. If you ever see these little squiggles, and you can see the squills are shown in the scroll bar here as well. If there's a squiggle, then generally Alt-Enter will show you the fixes or suppressions or things like that. But it's also accessible on many other things. So for example, I could, oops, that did not do what I expected. Looks like I'm going to have to go and file a bug. Again, the perils of preview versions. But previews also have very exciting things like IoT and function support. And so the IoT and function support are in preview. We would love to hear what you think of them if you try them out. And you can give us feedback on developer community, which you can access from the little help, report a problem, or provide a suggestion. And you can also tweet at me if you have comments, questions, feedback. Okay. So that was IoT, but wait, there is more. Even though I covered a lot of different things, there are a couple more things that I didn't mention that I'd like to talk about briefly. There is a very exciting side project of mine. This was originally developed by Xamarin, but was put on hold. And about a year ago, I picked up and started working on it in my spare time, which is support for writing Unreal Engine gameplay code in C#. This is fully supported in Visual Studio for Mac. You can open, build the projects, debugging and navigation between VS and the Unreal editor are still in the works, but will be out soon. So this is the other big game engine. It does some things that Unity doesn't, does some things better, some things worse. Some people like it. It's kind of like Windows or Mac. Some people like one, some people like the other. But we wanted to make sure that even if people wanted to use Unreal Engine, they still have the option of using C#. So this project is currently in a very early preview. To check it out, you have to build a patched version of the engine. A huge amount of C++ takes a while to build. You can access this on the URL shown here. It gives a full binding to anything exposed to the Unreal scripting system. You can access from C#. You can subclass Unreal objects. It's super neat. And there is one other very cool thing that, again, I wasn't able to show today, but this is NetDuino. Some of my friends over at Wilderness Labs took the NetDuino project that was originally developed by Secret Labs and have given it a new lease of life. It's really exciting what they're doing with it. These devices are now available again. These are little embedded ARM devices that have literally a few hundred kilobytes of memory. These are true embedded devices, and it's very analogous to an Arduino. It's even compatible with the Arduino pinout, so you can get Arduino compatible hats and put them on top. But unlike Arduino, which you have to program in C with a very limited IntelliSense experience and so on, this is C#. It's running on the .NET Micro framework. It doesn't currently support .NET Standard, but and I don't know exactly when that might be supported, but I'm sure it's something that will be on the roadmap at some point. It's super exciting, and I would recommend checking that out. So, wrapping up, we saw that Visual Studio for Mac is a comprehensive .NET development experience on the Mac, no matter which platforms you want to target. You can do it all in one place. You can share code using .NET Standard. You can target cloud using ASP.NET Core and Azure Functions for serverless. You can write Mac desktop apps with Xamarin Mac, and you can write IoT. You can use IoT both for more serious IoT devices like the Pi, or even for tiny embedded devices like the Netduino, and also for games with both Unity and Unreal Engine. So I have here a few links for, if you don't have Visual Studio for Mac installed, you can get it at ak.ms/vsmac. We also have some fantastic docs. Our docs team has done really great work on explaining how to use the various features and the features that are available and so on. And we also have some really great labs that all of the things that I covered very, very briefly today, the labs are detailed walkthroughs of from getting started step by step how to accomplish a task. You can work your way through. And there are labs for ASP.NET Core and Unity and Azure Functions and IoT and all of these things. So I'd also recommend you check out your labs, and we'd love to hear what you think of those too. So I hope you have fun using Visual Studio for Mac, and I'd love to hear any more feedback you have. I have not noticed any more questions, but if you had a question that you wanted to ask, but didn't think of, or really anything you come up with later, feel free to send me a message on Twitter, and I will very happily answer questions that people send me on Twitter, and I'd love to hear what you think.